For centuries, coffee has been more than just a simple beverage. It has become a catalyst for cultural exchanges, an economic engine, and a feat of botanical engineering. But how did a wild plant manage to become one of the most traded agricultural products on the planet? Colonization spurred the industrialization of cultivation. In 1714, a plant of Coffea arabica arrived at the Jardin Botanique de Paris, and from there, cuttings were taken to Martinique in 1723, initiating French plantations in the Caribbean. By 1770, the French colonies were exporting thousands of tons annually to Europe. The Dutch perfected cultivation in Java through terrace and irrigation systems, achieving yields superior to those of Yemen. Mechanization advanced in the 19th century with machines such as the hydraulic depulper, which drastically reduced processing time. It was also in the 19th century when coffee was consolidated as a product with global reach. With the growth in demand, the optimization of cultivation became a priority, spurring improvements in agricultural techniques. In Africa and America, the adoption of modern methods from the mid-20th century allowed production to scale. The process began with seeds selected for their genetics, germinated in nurseries with controlled irrigation, thanks to technologies that began to expand in the 50s. After 4 to 6 months, the seedlings were transplanted to mineral-rich soils located in high-altitude areas that favored sugar accumulation. In mountainous regions of Colombia and Ethiopia, manual harvesting, rooted in ancestral practices, prioritized quality and required up to 15 workers per hectare in steep terrains. In contrast, in the plains of Brazil and Vietnam, mechanical harvesters with sensor technology, adopted since the 1980s, processed close to 2 tons per hour, halving costs and allowing these countries to lead a production that, in the 21st century, surpassed 10 million tons annually combined. Currently, Brazil and Vietnam contribute approximately 3.5 million and 1,800,000 tons, respectively. In the post-harvest processing of coffee, methods such as washing, which consumes around 20 liters of water per kilogram of bean, and sun-drying remain fundamental. This high water consumption has spurred the search for more sustainable practices in various producing regions. This phenomenon, in which technology and innovation play an essential role, has turned coffee into one of the most traded raw materials after oil, generating around $200 billion annually. However, this pursuit of efficiency and the domination of large players have spurred practices such as Torrefacto coffee, which prioritize profitability over quality. Torrefacto coffee emerged in the early 20th century as an industrial solution to make use of lower quality beans. During roasting, sugar is added in proportions that range between 10% and 15%, generating a caramelized layer that increases volume but reduces quality. This method, initially associated with practices in Spain and Latin America, reaches high temperatures that can exceed 200 degrees Celsius, which favors the formation of compounds such as acrylamide, flagged by the European Food Safety Authority as potentially risky because it has been associated with possible carcinogenic effects in animal studies, generating concern about its impact on human health. Despite criticisms of its quality, Torrefacto coffee remains popular in various regions due to its lower cost and sweet flavor, making it attractive to both producers and consumers. Since 2018, the European Union has established strict regulations on acrylamide levels to protect public health, requiring producers to comply with specific limits. Meanwhile, in various Latin American countries such as Argentina, Brazil, and Uruguay, Torrefacto coffee continues to be widely consumed and marketed, representing a significant portion of the market, where it is appreciated for its affordable price and its characteristic sweet and intense flavor, without the same regulatory restrictions that exist in Europe. Technologically, Torrefacto requires adapted equipment. Unlike conventional roasters, which use hot air and rotating drums, Torrefacto systems integrate mechanisms to dose liquid sugar. These adaptations, implemented in countries such as Brazil since the 70s, prioritize efficiency over the sensory profile. Traditional coffee is roasted between 8 and 12 minutes, while Torrefacto may require longer cycles to achieve uniform caramelization, increasing energy consumption. This contrast in roasting methods has also sparked an intense debate about regulation and transparency in the coffee industry. Since 2016, countries such as Chile and Peru require labeling of products with high sugar content, which has impacted Torrefacto coffee sales in urban areas. However, its persistence in rural areas and emerging economies reflects a gap in access to quality coffee. Some companies have attempted to modernize the process with thermal controls to reduce acrylamide, but the essence of the method, masking defects with additives, continues to generate dilemmas between accessibility and quality. In turn, in other producing countries, such as Costa Rica and Ethiopia, advanced technologies are being implemented to optimize the cultivation and processing of coffee. In Costa Rica, drones equipped with multispectral sensors, implemented by the Costa Rican Coffee Institute, allow for mapping plantations with high resolution to identify water stress and optimize agronomic management. These technologies have demonstrated increases in yield under controlled conditions. In post-harvest processing, optical sorters such as those from Buhler analyze hundreds of beans per second, detecting defects with accuracy exceeding 90%. Roasting is also evolving. Systems such as those from Probat employ advanced sensors to adjust roasting profiles in real time, ensuring consistency in industrial batches. Since 2018, the Colombian Coffee Federation has collaborated with IBM on a blockchain project to improve traceability, an initiative noted for its potential to add value. Although the use of technology in coffee production remains predominantly traditional, some emerging innovations, such as hydroponic cultivation, which allows coffee to be grown in a controlled, soil-free environment using a nutrient-rich solution to feed the plants, and agricultural robots are being explored in experimental contexts. In some agricultural projects in Australia, automated agricultural technologies have been developed, but the use of robots with three-dimensional vision applied to coffee harvesting is still in experimental trials. Meanwhile, in Rwanda, mobile applications such as Coffee Doctor help small producers diagnose pests or plant ailments. Despite technological promises, the coffee industry faces a silent but growing threat: climate change, which endangers the very sustainability of production. This phenomenon directly affects coffee crops, altering not only productivity, but also the quality of the harvest. In Colombia, studies by the National Federation of Coffee Growers indicate that around 30% of farms have experienced productivity losses in the last decade due to heat waves and pests. In Ethiopia, projections from World Coffee Research suggest that up to 60% of coffee-growing areas could become unviable by 2050 if current climatic trends persist. If this were to occur, not only would one of the main sources of income for millions of small farmers be lost, but global coffee production could also be destabilized, leading to a significant shortage of beans and a drastic increase in prices, affecting both consumers and the global economy. In the face of this growing threat, the industry is seeking innovative solutions to mitigate the impacts of climate change. In response, the industry innovates. In Nicaragua, the hybrid coffee stamaya, developed to withstand droughts, is cultivated on thousands of hectares. This hybrid has demonstrated effectiveness under extreme conditions. In Brazil, producers are implementing soil sensors to optimize irrigation, reducing water consumption by up to 30% on modernized farms. Meanwhile, in Finland, the VTT Research Center is developing laboratory-grown coffee from plant cells, a method still experimental and costly, with initial prices exceeding $50 per kilogram. In Guatemala, reforestation projects using drones plant up to 3,000 native tree seeds daily, contributing to protective microclimates, according to the organization Biocarbon Engineering. Although access to these technologies is limited, digital initiatives such as direct trade platforms in Ethiopia allow small producers to sell to international roasters, improving their profit margins. The future of coffee could depend on what happens in the next decade. While large corporations invest in regenerative coffees and startups develop laboratory-grown beans, small producers demonstrate that innovation is not always measured in resources, but in the ability to adapt or disappear. Will coffee survive the effects of climate change? The answer could redefine not only the flavor of this beloved beverage, but also open new doors for the producers who keep this tradition alive. Amid these challenges, the responsibility also falls on consumers, who, with their choices, can drive a change towards more sustainable and equitable production. Ultimately, the future of coffee will not only be decided in the fields, but in every cup that we enjoy.